Today we're going to talk about converting between logarithmic form and exponential form. And here we have a little picture of John Napier, who was the inventor of logarithms. So an equation in exponential form looks like this. We have a to some power equals c. This same equation in log form would be log base a of c is equal to b. Now notice the placement here, that a is a subscript and log c equals b are all the same size. So we just here have a as a subscript, kind of the opposite of our exponent, which is a superscript. So if we were given, let's say 5 squared equals 25, and we're asked to write that in log form, that would be log base 5 of 25 equals 2. And going the other direction, let's say we had log base 2 of 8 equals 3. To write that in exponential form, we start with the base, so we start with 2. We go from the base to the exponent here, so 2 to the third. 2 to the third should be equal to 8. 2 to the third equals 8. So let's say we were asked to simplify log base 2 of 8. So remember that this is a way of expressing an exponent. This is really asking us 2 to what power gives us 8. Now some of you may be looking at this saying that you know that this must be equal to 3, and you'd be correct. Now let's say you're not so sure. What I suggest you do is set this equal to x and then write this in exponential form. So remember, this is the base, so we start with 2. This would be 2 to the x is equal to 8. So let's write that down. 2 to the x is equal to 8. And now we've got an equation where we can create a common base. So that's 2 to the x equals 2 cubed. So x must be equal to 3, which means that log base 2 of 8 is equal to 3. And that makes sense here because 2 cubed equals 8. Okay, let's look at another example. We'll make it a little more complicated, and let's say we've got log base 27 of 1/3. So what this is asking us to find is the power that brings 27 to 1/3. That is 27 to a power equals 1/3. Now some of us can do this in our heads. The rest of us may want to set that equal to x and then write that in exponential form. So we start with our 27. We've got 27 to the x equals 1/3. 27 to the x equals 1/3. And I'm going to use a common base of 3. So the right side, that's 3 to the negative 1. The left, I've got 3 to the 3x. So that means that 3x equals negative 1 and x equals negative 1/3. So log base 27 of 1/3 is equal to negative 1/3. This means that if we raise 27 to the negative 1/3, we would get 1/3. So we're going to do the same exercise now, except with a natural logarithm. So let's say we needed to simplify ln of e squared. We're going to remember that ln is really log base e of e squared. And what we do is set this equal to x, and we're going to write this in exponential form. So we start with e to the x is equal to e squared. So here we go, e to the x is equal to e squared. Now notice we already have a common base. e, and e, so the exponents must be equal. X is equal to 2. So this means that ln of e squared equals 2. Now let's look at another example. Let's try ln of e to the 7th power. Now again, this means log base e of e to the 7th. And what we'll do is set this equal to x so that we can write it in exponential form. We start with the base, e to the x equals e to the 7th. We have common bases, so we can just set the exponents equal. So x is equal to 7, which means that ln of e to the 7th equals 7. Now take note here of what happened. We got here that ln of e squared is equal to 2, and here we got ln of e to the 7th is equal to 7. And that's going to be true, where if you take the ln of e to any power, that will simplify to just be the power. And we can write that generally as ln of e to any power is equal to that power. This is definitely a rule that you'll want to write in your organizer and have memorized. One expression that comes up often is just the ln of e. Now you want to remember that this is e to the 1st power, which means that this will be equal to 1. Another expression that comes up is ln of 1. So let's work this out, see what happens. This is log base e of 1. We'll set that equal to x and write this in exponential form. So we'll have e to the x is equal to 1. E to the x is equal to 1. So we'd like to have a common base, and e to the 0 will give us 1. So x must be equal to 0, which means that the ln of 1 is equal to 0. So these are also some good expressions to have memorized, that ln of e is equal to 1, and that the ln of 1 is equal to 0. Now let's say we reverse things, and instead of looking at the ln of e squared, we looked at e to the ln of 2. Now this is an exponent, this is not in log form, but let's set this equal to x. So again, this is an exponential form. We're going to do the reverse. We're going to write this as a logarithm. So this would be log base e of x is equal to the exponent, which is ln 2, right? Log base e of x equals ln 2. So you'll notice here that we've got log base e, and we know that that is ln, that's our natural log. So we've got ln of x equals ln of 2, so x must be equal to 2. So that means that e to the ln of 2 is equal to 2. Let's look at another example. If we've got e to the ln of 7, we can set that equal to x. We'll write this in log form. Log base e of x equals ln of 7. So this is log form here of this exponential equation. We've got e to the ln of 7 is equal to x. Log base e can be written as the natural log. And here, this means that x must be equal to 7. So e to the ln of 7 is equal to 7. So we can see here that there's also a general rule that if we raise e to the ln of a number, we get that number. So e to the ln of 2 equals 2, e to the ln of 7 equals 7. So e to the ln of x is equal to x. And here is another good rule for your organizer. Our last part is finding missing parts of logarithms. Sometimes we're not just simplifying. Sometimes we might actually be solving for a base. For example, we might have log base x of 100 is equal to 2. So we treat this the same way. We'll write this in exponential form. We start with the base, x squared is equal to 100. So we know that x must be equal to 10, which makes sense because 10 squared equals 100. Or maybe we see a problem like this, where we've got log. We know what the base is, but we need to find this value. And let's say that this is equal to 3. So we write this in exponential form. 5 to the third power is equal to x. And 5 cubed is 125. So that's our answer, and that makes sense because 5 cubed is 125. So in summary, we've got this relationship between exponential form and logarithmic form, that the base here can be written as b to the x power is equal to y. And here you have that, b to the x is equal to y. A few other things that you might want to take note of would be that the ln of e to a number will be equal to that number, which means that the ln of e to the first power is equal to 1. We also saw that the ln of 1 was equal to 0, and that e to the ln of a number was equal to that number. So all four of these, including this expression here, should be written in your organizer and memorized.